welcome everyone. So we are here to learn some PLSQL programming. We're going to start at a very basic level and we're going to keep adding things on. And this is meant to be sort of a continuous tutorial. There's obviously going to be different sections. If you want to scrub ahead to those sections and see things you want to see, that's perfectly fine. There's not going to be a lot of external scripts. I'm not going to load a lot of files you have to do to prep. Everything is going to come pretty much straight from Oracle out of the box. But we will take a different approach to learning this programming language. Instead of trying to learn all the rules and syntax and basics, I'm going to delve right in. We're going to start writing code that works. And as we go through the different sections, I will expand your knowledge of what's actually happening behind the scenes. I don't want this to be a tutorial where I go from very basic to a quantum leap and you have no idea how I got there. Everything will be explained. That being said, you don't need a lot of programming experience to be here. I hope you have some SQL experience. You should be able to do basic queries, select, insert, update, delete, have some knowledge of what tables are, and some reason to be using Oracle. The reason you're trying to learn PLSQL programming is because you have an Oracle database, and there is just a wealth of additional capability you have when you learn PLSQL. So that's why we want to learn it. You don't have to have set up your system the way I had in the little intro there. You can use any Oracle database. You can use any version of SQL Developer pretty much. It can be on Windows, can be on Linux. I am running this SQL Developer on Mac OS, and I'm running the Oracle VirtualBox as per the Jeff Smith video to have the Oracle Developer virtual machine. You can do this at work against your own Oracle database. You could be running Windows with Oracle Express and have it local. That is all your decision to make. All I need you to have is SQL Developer and a connection. Now, I'm going to use the HR schema, the account that comes with Oracle, the demonstration account, which if you load the Jeff Smith Oracle VirtualBox image, it is on there automatically. Any sort of default Oracle install also has the HR schema. Your DBA, if you're in a work environment, may have removed it. Often the demo schemas are removed for security purposes. That's okay. You can use any set of tables you want. You just want to kind of follow what I'm doing. Or you can talk to your DBA and see if they can get you the scripts. Oracle does ship with the scripts that make the HR tables, and maybe they can put them back in the database for you. So we have to have some tables to work with. I'm going to use the HR tables for this particular tutorial. Maybe we'll then make some of our own tables as we go. So what you're looking at on my screen right now is SQL Developer. Download from Oracle. This is version 23 again. I got a pretty recent one for this purpose, probably similar to something you would get. And I have the connection to my Oracle VirtualBox, and you can see that all I really have here are the tables. Now, in SQL Developer, if you're sort of new to this integrated development environment or this IDE, it shows you a comprehensive summary of what's going on in a schema, which is an account in Oracle that owns something. And the human resources schema has all these tables here. There's also a view, and there's a few indexes in here that are built, go along with the tables. There are no code objects. PLSQL is considered a code object that lives in the database. Those are your procedures, functions, and packages. And there are none of those things in this schema to start. So we're starting completely basic. No pre-written code. I'm not just going to jump in. Everything else is another feature of a schema. We may use some of those like sequences. We may even look at a trigger or two. Definitely going to look at some types. But for now, we just have our tables, and we're going to be building code objects. Just as a overview in SQL Developer, this is a script area. We're going to be generating code. We will use a few column wizards also, or some little helper screens to make code as well. But everything comes down to an SQL statement at some level. And we're going to be creating things. So we have tables that were created. We have a view that was created. We're going to create some program objects. On my Mac, it might be a little different, but there is a menu if you look at the SQL Developer up here. And if you want to set any kind of preferences, it may be preferences in Windows. There's a settings option, and here you can change the environment. And I will tell you the one thing I did before we started was I took the code editor option here, and I took the font and I bumped it up to 17 so that you could see my font a little better. And the only other thing I did was on the line gutter, I enabled the line numbers. That's so that I have this line number here. Again, So if you need to set anything, it's probably preferences on Windows, but on the Mac, it's settings, come in, and then pick the settings. We may look at a couple other settings as we go through these sort of tutorials here. That's all I did. Nothing else is staged, nothing else is set up. So what we're gonna do, I'm gonna give you a real quick little overview of why we have PLSQL and Oracle. I say we, I'm not with Oracle, I'm just a private guy like you, but I've been with Oracle so long, I feel like it's a we sometimes. So why do we have it, and what can we accomplish with it? And there are people out there that don't like to write PLSQL. I think that's fine. The problem is you paying this money for an Oracle database. It has a ton of capability, and almost all of that add-on capability comes in the form of some type of code object, some type of PLSQL object. So PLSQL really is just a procedural language. That's the PL that's wrapped around SQL. SQL can do great things, right? Insert, update, delete, select, all kinds of joins, all this cool stuff. We can do reports and sorting, but it doesn't have a lot of thinking. It doesn't make a lot of decisions. Sometimes we need that procedural logic, right? Oh, if something happens over here, I want to run this query. Or if something else is going on, I want to run this query. Or if the value in this column is 10, I do this function, right? We want to be able to have these options here. Also, procedural is just that. It's procedural. Do this thing in the order I tell you to do it. These are the standard operating procedures for maybe putting a record in a table. If you can figure out what those are, you could code those in PLSQL, so that no matter who is adding a record to that table, they follow the same steps. I don't think as a database administrator, we like to give a lot of people low-level insert capability, right? I don't want people hand-coding insert statements into my tables. They're likely probably to make a mistake or just make really garbage data. We can make procedures that would do that. We're going to do some of those in this tutorial. The other thing with PLSQL is a lot of really advanced things you want to try have been coded for you. There's a lot of high-end mathematical things Oracle will do that are in PLSQL. There are security packages. There are logging packages. There's a lot of great stuff. So almost every add-on to the Oracle database comes in the form of a PLSQL package. We will be making our own packages as well. We're going to follow the exact model Oracle uses and try to be like them, but for things that matter to our domain, to our set of tables, to our application. You will hear people say, I can write all this code in Java. I can write it in Python. I can write it in C#. And that's true. You can make all the logic code you want in those and put them in your application, and that's fine. Those work in those applications. It's not as easy to write a reusable Python component that Java can call if the next application version is Java or it's coming from an iPhone app or something. You can. I mean, there are, we can make listener technologies and we can, web APIs and things like that. But PLSQL, if I write a procedure to update a record a certain way, no matter who connects to the database and calls that update, it's going to do it. So I like it for that. The other thing is for what about large processes like extract, transform, and load? I want to kick off a job that's going to run all weekend and move 25 million records from one table into 16 other tables and build maybe a data mart or part of my data warehouse. PLSQL excels at that. Back-end jobs that can do things without us watching and can periodically log. I don't need to be a front-end or a mid-tier application programmer to learn how to do that. If I'm a data analyst or I'm a data expert or a data architect, my wheelhouse is the database. Well, my wheelhouse go-to programming language is in the database, and it's PLSQL. So all good reasons to have it. So you're here for whatever reason. We want to learn how to do the code. I will do my best to give you code that is clean and easy to understand and also follows good form. I'm not going to follow into a particular paradigm except my own. Nothing is exactly perfect. People might say, oh, that's not a best practice. Well, my best practice for you is what gets the job done accurately, securely, and can be reproduced, right? Is it testable? At that point, write code you can maintain. Copying a bunch of code from a Google website that you can't maintain is not going to help you because at 3 o'clock in the morning when it breaks, how are you going to fix it? We need to be able to write our own stuff. So let's delve right in. We're going to talk about, again, not a bunch of syntax. I want to do something in the database. I want to write a procedure that does something, probably around one of my tables. Well, to create anything in an Oracle database, whether it's a table or a view or an index, is the word create, and procedures are no different. So I'm going to do this in a very simple way first to show you how to do it, and then we'll see how PLSQL SQL Developer can help us as well. So if I want to create a code block, I can use the word create. And whenever we're doing code in Oracle, we can add this or replace option. And what or replace says is create the code if it's there or overwrite it, create the code if it's not there or overwrite it if it is. Because as you're developing code, your program goes through iterations, and I don't want to have to keep dropping it. As you know, to get rid of something in the database, we use drop. Well, I don't want to have to keep dropping my code. So create or replace, very useful for saying build it if it's new and overwrite it if it's not. And then I got to tell it what kind of program. We're going to start with something called a procedure here. A procedure is just something that does something. Procedures do things to things in the database. They do what you tell them to do in the order you tell them to do it. And let's just call this procedure, we're going to use the ubiquitous, right? We're going to call it first proc, okay? Just for now, we're going to do something a little basic. And then what happens is, you'll see the word is or as. They both work. And then you'll see an end. Procedures are what we call blocks of code. And in Oracle, a block of code comes between begin and end in a very basic sense. It means, listen, I am this named procedure, and after the is says, I am all of this, and anything you want to do goes between begin and end. Now, you may be very familiar with SQL, and in SQL, we have the concept of a statement, right? So if we have an SQL statement, I'm going to come down here in this window. If I say select star from jobs, that's a statement, and it ends in a semicolon. So if I run that statement, I can see the data. All statements end in a semicolon. Okay, fair enough. Why are you telling us this? We know that. Well, create or replace procedure. This is a statement to create a procedure. It ends with the semicolon. Begin doesn't have a semicolon. What you are doing is you're submitting a statement to the database to build a procedure. Cool. All you do is then sandwich in between begin and end every other statement you want to do, and it will do those statements. Every procedure must have at least one executable statement. If you don't know what you want to do, we typically throw the null in there. Null says do nothing. It says just simply do nothing. I can create this procedure, and it will say when you run it, it will do nothing. But this is syntactically correct, and often this is where we start. If you use the Oracle SQL Developer code generator for procedures, it does this for you. It does the same thing. Let's talk a little bit about this. I'm just going to build this by taking this script, right, and I'm going to run it here with either button. And you see it says compiled. It doesn't run the code. It's building the code. Where does it put the code? Well, the code goes into the Oracle database, into my account, which is the HR schema, right? And then over here, I will see that. It doesn't always refresh, but if I come over here and hit the refresh buttons here, which are the two blue arrows, you'll see I have a procedure now. It is now persistent in the database, right alongside my tables, my views, my indexes, my sequences, my triggers, everything else. It's a database object. If the database is backed up, this code is backed up. If I export the database schema, it's exported as well if it's selected. So I can log off and come back. This will be here tomorrow. Perfect. This is just the script that made that, like me typing it manually here. The name follows the same Oracle naming conventions of any type of thing you want to do, right? So the same Oracle naming conventions are, it can only be a certain amount of characters long. It must start with a letter. It can only use certain special characters like underscore. It can't be a reserved word. No procedure is called procedure, right? Things like that. So the other thing is it must be unique within your schema, within your account. I can only have one procedure called first proc. If I try to make another one, it won't work. That's like I can only have one countries table in my account. It would be very confusing if there were two. So I created a procedure called first proc here. That's not the only way to make a procedure. This is just me typing SQL commands very low level. Let's erase this. Okay, let's close this countries down. Sorry, that popped up. If I want to make anything over here using the Oracle Connection Manager, I can right-click on it and say new. Here's a new procedure. Let's see what this does. It says, okay, what are you building? A procedure. What do you want to call it? Oh, okay. Well, let's call this one second proc. And I'm not going to do anything else. I'm not going to add parameters. We haven't talked about that. Don't worry about the source in lowercase. I'm just going to add it. It's telling me what account am I using. HR is the only one I have, so it's selected by default. And I say okay. And look what it did. It's basically the same thing. There's one subtle difference here that you're not seeing, okay? This is now in a PLSQL editor. You notice this little gears here to compile. If you want to save this, you hit the compile button and it'll pop up and it auto refresh now. You'll notice the end of this procedure has the name that we named it. That is very good form. It is not 100% required, but it is nice to know which end goes with which named procedure. because right now we're building standalones. When we start to group them up into packages, you're going to have a lot of begin ends, and it's really nice to know who the end goes with. So let's say we want to edit our first procedure to follow this paradigm here. All I have to do is come over here, open my first proc by double-clicking it, and it will bring the source code up in an editor. See this editor here? This is the procedure editor. I got my gears now, and I can simply take this text and I can paste it on here. And then if I hit compile, first proc's updated. Case sensitivity, let's talk about that. PLSQL doesn't care. You want to use uppercase, you want to use lowercase, that's fine. Names, as you know in Oracle, everything gets stored in uppercase, right? Even though I'm putting lower here in my actual source code, it builds it in uppercase. That's fine because Oracle doesn't care. The only thing case sensitive is actually literal data. When we get to literal data like character strings, we'll worry about case sensitivity. But for now, it doesn't matter. I like to follow some standards. The create or replace doesn't matter too much to me, but in my blocks of code, I like the reserve words to be in uppercase and the names of things to be in lowercase. It just helps me identify what I typed versus what Oracle is using as a reserved or what Oracle generated. So we have two procs right now. Very easy to do. They don't do anything, but they both are valid. To show you that they exist beyond what we just did here, if I disconnect, if I right-click and disconnect, I'm dropping my database connection. They are gone. I can kill this script output window, kill this messages log. I can even close SQL Developer. I'll save you the effort. It takes a while to start up. But if I reconnect and I browsing and I come to my procedures, they are still there. They are persistent in the database. You created a database resident program called a procedure. How can I actually tell Oracle, run that procedure? I want to see what it does. Very easy to run a procedure. You have a couple ways. One is, if you are clicked on it, there's a run button here. This run button doesn't just run it. What it does, it's going to build you a little test script that you would basically run. The same thing you could type for yourself. Let's click this and see what it does. You get this little run PLSQL widget here, and it says, here's what I'm going to do. I'm trying to run first proc. There are no parameters. And I'm going to build you this block of code to run it. PLSQL runs in blocks of code. Procedures are executed by calling them with their name. That's all you have to do. This rollback is a comment. It means if you did something and it was data, they're giving you a free rollback here. We don't need that. We don't have anything going on. It's just Oracle trying to be helpful. This little script here is built from a template in SQL Developer. If you don't like that template, you can edit it down. I'm going to leave it. This just says, I want to run first proc. What the open close paren are indicating is an empty parameter list. Not required, not bad form to have it, okay? Syntactically, if you have no parameters, you don't need that, but it follows the paradigm of a lot of other programming languages. So this says, this is what I'm going to do. I'm going to run this, and it's going to run it on your current connection. If I hit OK, what you'll see here is down here, let's bring this up. Process exited, didn't do much because we didn't do anything, right? And if I look at the output, there's no output from this thing. If I look at statements, there's nothing. There's no logging. That's just my standard error logs for SQL Developer. Nothing. We didn't do anything. It doesn't do much. You can do that yourself as well. So if I want to run it with my own script, I have a couple options. I simply build that script. I can run it with the run script button, the run statement button, or push my mouse up on the top up here and it'll run whatever's in the window. I'm going to suggest in the beginning to use the run script button, and I'm going to show you why. When you run it as a script, the script window comes up and it actually gives you a nice kind of comforting message that PLSQL successfully completed. So that's very useful, especially if we start displaying things. So that's how I can run the procedure. This block of code, when you see a begin end with no create or replace, means you're not building it. It's not storing it. It's what's called an anonymous block. Anonymous blocks do not have a name. They're not objects in the database, but they're running code. PLSQL runs inside of an anonymous block. There is one other way you can execute this. Inside of the Oracle engine, the word execute will work. All right, if I run execute here and I run this, it'll run it. Execute is nothing more than like a macro, and it puts begin end around your program. So there's nothing magical about it. That's what it does. So typically when we're doing testing, I don't use execute a lot. I like to use my own little block of code. So I might want to do some other things in here. All right, so that's where we are right now. We can make a procedure. We know it's saved to the database, and we can execute the procedure. If I want to edit the procedure, I can simply click on it and bring it up. If I want to get rid of a procedure, I can simply right-click, and I can say drop. Now be very careful here, because drop is the same way you do drop in the database. Oracle doesn't care there's dependent programs on a procedure. It's just going to drop it. It thinks you're in charge. You're connected as HR. So you might want to make sure that you've done your due diligence before you blow something away and make sure it's not being used, all right? There are some ways we can check on this, as we'll see later on as we go through these tutorials. But for the most part, you need to know what's happening. You should definitely make a check to see, hey, is that being used? Now, on a little development system, the only person you're probably hurting is yourself. But it can set you back when you drop something. Oracle, if you have a good DBA, they can get your code back from the night before. They can restore it. You know, they might have flashback running or whatever. Let's not count on any of that. Let's make sure that, you know, hey, we're on our own. Let's just see if we can keep things running and not destroy stuff. There's nothing stopping you from copying and pasting this into a file and checking into source control as well. That's not a bad idea at all. SQL Developer will hook to certain source control systems so you can save your code. For now, I'm not going to assume you have any of that. All right? Put it in a file. Save it in a file somewhere. So when I want to edit this, I'm going to come in and do some editing. One thing we do in code is we make comments, right? Comments in PLSQL are the same as SQL. There are two types. There's the single line with dash dash. We can do that. And then we can do the multi-line, which use /star, multi-line comment, and //. Perfect. Those both work perfectly good. They are not executed. They are simply part of the body of the code. They are saved in the database, but they won't do anything. They will not execute. So if I come and run this, not going to hurt anything. It's simply going to run and say that the procedure is successfully completed. Perfect. That is something we are used to in SQL, and it is exactly the same. Let's do something different here within the procedure. And I don't want to do the standard, let's print hello world. We're not doing any of that. Procedures are meant to do something in the database. Let's write a procedure that's going to work with that jobs table. The jobs table has 4 columns in it. It has job ID, title, salary, min, and salary max. Maybe we want a procedure that inserts a row into that table. Now, we know how to do an insert. Insert's not a hard thing. In fact, we can try that out. Let's clear this off. Let's look at the job table. Let's do an insert statement. How would we do that, right? We would say insert into the table jobs. And then typically, we list the columns we want to insert into, right? Job ID. Looks like that's an underscore. Sorry. Job title. Min salary, keyboard challenge today, I apologize. Salary, max salary. All right, and then what we can do is the values keyword, and if you know Oracle or SQL, it's positionally lined up. I must give it a job ID, a title, a min, and a max salary. Well, if this jobs particular table here, it looks like the job ID is a character, not a number, but it's the primary key, all right? The title is character, 35 bytes. Then we got 2 number 6 comma zeros, which are the salaries. Let's take a look at the data. SQL Developer lets you look at data pretty easily with this data tab here. And I can see, okay, there's some ID. So let's just add a new ID. Let's see, what kind of job do we want to add to the system? Let's add an IT guy. All right, you got IT programmer. How about just IT guy or IT manager or something like that? So, and what's the salary? Oh, we got to give him a little more money. All right, so we can come in here and we can put these values in. We'll call IT manager. That's the first value. The title will be, you know, information tech. I can get the capital T, trust me. There it is, manager, all right? And then we'll make the minimum salary on this one 8,000, and we'll make the max 15,000. There we go, okay. So if we insert this row, we're to insert that row, the row's inserted. Now, I have not committed that row. In SQL Developer, if you're just kind of playing around, there is a commit button here. Hopefully you know that you can commit that record. It'll commit that session. If I come back here and I refresh, then I can see that IT Manager right there is in the table. One thing about SQL Developer, if I don't like this row and it's not being used, there's no keys to it or anything, I can click it and I can delete it that way. I can also do my delete commands. We're going to be using a lot more commands. We're not going to use the interface like this. I'm just being expedient here to show you I can add and remove that row. I don't want to do that. I want SQL Developer to do this for me. I want to run a program that puts this into the database. So let's take this command and we'll put it right into first proc here, okay? Just really basic. Put it in there. Whoops. Sorry. Just do that. That's not very reusable, but it will work. Now, if I also want to save that, I can code a commit in here. Let's compile this. All right, good. Compile successful. Messages log gets a little busy. You can clear it if it bothers you after a while. I like to clear it. I like to close it too. It actually annoys me that it pops up so much, but you might want that in first. Now I have this procedure. Can I run this procedure? You bet. Let's go back here. Let's clear this off. If we go to our history here, you'll actually see I can pull up the history, right? Or I can type this again. Let's clear this, and let's run this procedure. Ooh, I got to actually not select just one thing. There we go. You select whatever you select, that's what's being run. So let's go back. It said it completed. If I refresh the data, there it is. Perfect. Procedure does exactly what we wanted it to do and commits that. So that's great if I want to keep adding the same job over and over. Not very realistic, all right? Let's go ahead and delete that record again. Let's get rid of that record. And let's learn something here to make your programs more reusable, and that's the concept of a parameter. A parameter is something you hand to a program. It's an input, also called an argument. And it says, hey, I'm going to hand you this so you have something to use. So you don't have to hard code something most likely. So how can we pass these values in to this program so that it can use them and maybe insert any job? That'd be really good. Parameters, I'm going to comment this out right now. Whoops. Parameters are defined after the name of the program, and they go in parentheses. They go in a parenthesized list. So syntactically, after the name come any parameters. And parameters have the following format in a basic sense. They need a name, and they need a generic data type. What kind of data are they? So I like to name my parameters with P underscore, and then whatever it is. So if I'm going to pass a parameter for job ID, I would say job ID. What I need to tell Oracle now is, what's the family of data type of that? Well, that's a variable character. I do not put a length. No length or precision on parameters. Oracle adapts, all right? It will not take it if you put a length. So I'm going to have P job ID, and I'm at another parameter now. And I like to put these on separate lines. You can do whatever you like. P job title, okay? Let's put the job title in there. That one's also variable character. And then we have the P min salary. Now this one was not a character, it was numeric, so we can use number, which works really good. And then P max salary. Now, what are the limits on naming parameters? Well, they're the same as everything else in Oracle. Has to start with a letter, can't be a reserve word, can use underscores and things like that. And there's a certain length. You know, that length is determined by your value of Oracle. Let's just go with 30 characters for now, okay? It can be longer, but let's just say 30. That'll give you a lot of backward compatibility. So I have these parameters now. What this means is when I call this program, I'm going to have to hand the program these values, or it will break. We haven't done anything about defaulting or anything like that. How do I use them? Well, instead of hard coding the values we did here, anywhere you had a value, you can drop a parameter that contains said value. So let's go ahead and take all of these off. And all I have to do is, in the same positions, put my parameters comma separated. One thing to know about PLSQL, whenever there's more of one of something, it's comma separated, okay? Parameter list, or in this case, my value statement. And I'm going to do this. Now, It's very important to know these are positionally lined up. It's not by the name. It doesn't care about the name. What it's saying is, I'm going to take whatever's in P job ID and put it into your first parameter, insert to job here. I'm going to take whatever's in job title and put it here. Insert uses positional notation, right? So this parameter goes here, this parameter goes here. Got to get it right. Obviously, if I mix up min and max salary, Oracle wouldn't know which one's the min and max. They see some number, right? If I try to put job title into salary, yeah, it would break. The insert wouldn't work. I can't put a character, that contains words into an integer field there. Okay, so this is going to try to insert anything we pass in. Let's compile this. So we got a nice compile. We know that syntactically the code is good. How do we run it now? Well, I'm going to have you run it the manual way. All right, build your own script so you can see this happen. It's better to see. And what we have to do now is, I can't just call first proc. Let's see what happens when I just call first proc. I'm not going to hand it anything. Let's see what Oracle does. It says, hey, I got a problem here. And it's always at line 1, isn't it? It's always at line 1 when you're doing an anonymous script. It says, when I got to line 3, wrong number or types of arguments in call to first proc, meaning you didn't call this correctly. You either have the wrong number of parameters coming in or the wrong types. They're not the right data types or some combination thereof. So, I don't know how that works. I need to know what first proc expects. What if I never used it? Where's the documentation on first proc? Well, I'm sure no one wrote it. So if we come back to our procedures here, we refresh, and I expand first proc, you will see under the procedure now, it tells me these are the parameters in the correct order, and it really shows you the data type. AB, character, 1, 2, 3, number. Okay, I got some idea how to call this. I don't know the lengths. I don't know what that table accepts. I have no guidance, but let's hack through it. Let's see what happens here. So if I want to pass parameters, much like defining them, they go in parentheses. Remember when that was empty at first and I said there are no parameters? Well, now we have parameters. And now we can put the values we want to put in. So I can put IT manager, right? And then I can put, information tech manager that we had before. And then put that salary of whatever it was, 8,000 I think we gave him, and then 15,000. Now, one thing SQL developers helping me with, it's like, since there's no red squiggly lines, it thinks, well, it looks good. Who knows until you run it. Maybe this is too long for that column. I don't know. We didn't do anything with that, right? Maybe this number is too big. Maybe there's a limit or a constraint. I don't know. Let's run it. So we run our program here. It ran. Let's go to our jobs table and refresh. And there it is. Let's try that with something else. How about IT help for information help desk? They're going to make slightly less, I would think, right? Maybe 4,000 to maybe, 7,000 or something. Assume that's a monthly salary or something. Can we run this? Let's see what happens. Here we go. Come back to jobs. And we got help. Beautiful. Now we have a reusable procedure that will add a record to the jobs table. Are we doing any error handling? No. What if the job already exists? We don't know. What if the values are too long for the columns? We don't know. We haven't done any of that. That's all stuff we're going to add on. But in a very basic sense, what you're seeing here is I can make a procedure that has a name, that has a set number of parameters that come in, and it can use those parameters in place of hard-coded values. That is what we're trying to do. This is a procedural block of code. The first statement is the insert, do that. The second statement is the commit, do that. So remember, when you're submitting blocks of code, Oracle is submitting first proc, which is everything from the word procedure to end. That's one statement, and you are sandwiching your statements in between. All right, as we do things, there's a semicolon, those are all statements. I can do any number of statements I need to make this thing do what I want it to do. That being said, safety tip, don't write giant do-it-all procedures. If you write giant do-it-all procedures, you have to debug giant do-it-all procedures. I would rather you write smaller, more modular procedures that do 1, 2 things well. So number 1, you can have very limited number of errors and you can trap for those. And 2, they're very easy to read, right? And then what you do is have larger programs that call those in order do this procedure, that procedure. And then you know when first proc is working, it always works. It's not the cause of your problem. Maybe it's something else in another procedure. Very easy to debug that way. Let's extend this a little bit, because when you're dealing with procedures, you're usually writing them for front-end, mid-tier programmers to use. Or maybe, you know, for some kind of batch script or something. But it's often good to know, did it work? They're not going to get a nice little warm fuzzy on a screen that says PLSQL successfully completed. They're probably going to call it and wonder if it's okay. If they don't see an error, maybe it's good. But maybe you want to be able to communicate with them. Hey, it worked, or it worked with this issue, or it didn't work, or whatever. So we have these 4 parameters. Remember I said parameters are things you pass in. Well, there's another type of parameter, which is something you can pass out, which means the procedure takes a few things in maybe or whatever and says, I'm going to hand you this back. And when it hands something back like that, that's called an out parameter. Procedures by default make all parameters in if not specified. So we didn't do this before, but if I'm going to tab these over so you have a little more alignment here. Technically, all the modes of these parameters are in. And the word in here says, you are on your way in. Sorry, I did not mean to erase that one thing. There we go. And that basically means it's going to be passed in from whoever calls this procedure. It also means they are immutable. Once job ID is passed in, it cannot be modified. All right, it's treated like a constant. So in parameters come in, they're treated like constants, and they can be used anywhere you'd need to use the value. Works perfectly good. You wouldn't want a parameter being modified. Someone passes one thing and you're manipulating it, right? So we want to just have those stay constant. The bulk of the parameters you see are in parameters. If I want to hand something back out, I must declare it with a parameter name as well. I can say, hey, p out message. But now I must say the word out. And then what data type is it going to be? Well, I'm going to send out a string message, so that's going to be a variable character. And again, there's no length. So this out message here is going to have to be set in this program. And when the program is done, meaning when it hits end, any out parameters will be bundled up and sent back to whoever called it. They don't go out asynchronously as the program's running. They get set, and at the end of the call, they get sent out. So if you have a program that takes 10 minutes to run, and you're expecting to see out parameters at the first, second, third, fourth, fifth minute as you're iterating through something, nope, that's not how it works. They go out at the end, all right? So if I want to put a message out here that says, hey, we inserted this, it worked pretty good, I can say, insert worked, something like that, right? Very basic message. And I would have to set, I'm sorry, I'm thinking I was calling a function for a second. I'm a little ahead of myself on the tutorial. Here we go. Sorry, assigned a value of that value. All right. In PLSQL, when you're going to put a value into something, whether it's an out parameter or a variable or something, we use this operator. The colon equals is the assignment operator. You can read that as assigned a value of. That's what I like to say. I am going to assign pout message a value of insert worked. It is a character parameter. This is a character string. We're looking good. That is an assignment statement. There's the semicolon, all right? So the insert statement, the commit statement, and then the assignment statement for that. Where does that get written to? Well, typically the front-end program would have something to grab this. They would call it and stick it somewhere in a buffer so they could read it. In SQL Developer, if we run a program, not using our own little block, but we use the Oracle run here, the built-in one, it will build us a little output to catch this, and then you can see it. Let's do it this way, then I'll show you exactly what's happening. If I run this, you will see that it builds me this block of code. Now, look at this block of code, right? It's building me a test block, and it's saying, wow, these are all the things I got to declare, and it's setting this out to 200. That's just a random number it's setting it to. It's not, I didn't tell it 200. That's just by default what it thinks it needs. We can always change that. And then it's setting up values. It's trying to assign all these parameters, these values, right? This is what we were passing in manually. And then it calls this. We're going to talk about this call syntax in a second. But this down here on line 23, this is the thing. This legacy output is just a comment. Don't worry about that. The rollback is just a comment. Don't worry about that. This colon here is a bind reference to a SQL developer sort of a variable, like a memory variable, that it can reference in this interface. And it's saying, listen, whatever you put in out message, I'm going to put in there so that this interface, this IDE, can display it. That's not a normal SQL thing. That's not a normal PLSQL thing. That's how this particular program, which is written in Java, by the way, binds a value, okay, into something it can see. Let's just go ahead and we're going to run this. And what we can do here is we can put sample values in this little test program here, right? So I can say, let's call this, IT analyst. We'll call IT, what's a better job? We can do analyst, that's fine. Analyst. All right. And then the job title will be information analyst. And then the salary, whatever, 6,000, and then maybe salary of, 8,500 or something. Oops. So this is like me typing them in our parentheses. This is building that. I'm going to get to this syntax here. It's a very simple syntax. It's just something we haven't taught you yet. But I want to run this. So basically, I'm going to run it. I'm going to put in my values, and let's see what happens. We're hoping to see a message. If I hit OK, the program said it exited, and now something we saw before that we said didn't have anything is this output variable tab here. The output variables says, oh, what's this? Wait a minute. There's an output. Yeah, the out parameter, the variable, the bind, the colon p out message has this value. This is what I put in there. So this here tells you what it was. This SQL developer is acting like I'm another program that's calling this procedure. It is. It's a Java program that's making a call to this procedure for you. And it's saying, this is what I got back from you. So we successfully set the out parameter in our program, right, to that message based on what we decided to do. Looking at the program, all we had to do was assign it. Had we not assigned it, it would not have gone out at all. Does that matter? Well, let's just comment it out and see. Let's run it here. Let's go back to our run. Now, the nice thing about doing the run here is, and we're going to have to make sure we clear this off. Hang on. We don't want the IT analyst in here. We got to kill that record. Okay. If I run this again, it will keep the bind information I used the first time. So I can do test runs over and over. That's what's nice about this little interface here is I can just keep trying this. I have to make sure I delete the row. I don't want two IT analysts. And as we know, that's the primary key. It would reject it. But I'm just trying to use this same data a couple times. It actually shows you up here too what you're putting in. Let's run it. Now I look at output variables. Nothing. I just didn't assign it. It doesn't care. It's called successfully. It just doesn't care. Okay. What if we want to do something else with that message? What can we do? We can say whatever we want. We can also be very confirmational, right? We don't just have to say something like this. Maybe they want to know exactly what happened. So I could say something like, hey, job, colon, and all SQL functions and operations are available to you. So concatenation works the same in here as it works in the database. I could say the job ID right here, and then concatenate on was created, right? And now I'm going to put out a little more custom message to the front end. We'll compile this. Let's go ahead and refresh this list and see if that's in there still. And it's still in there, so let's remove this. And we will run this again. Same thing. Go out, go to our output, and now I can see that I got a much nicer message. Out parameters are incredibly useful because what they allow you to do is communicate with who's calling. And often this is an agreed upon communication. A developer might say, listen, I'm going to call your program that puts jobs in the database. Can you send me back the name? I need the name and the word was created, or I need a word success, something they can key on so they can pop a message up on the screen telling people your job was created, or whatever the reason is. They can look at SQL return codes and things, but often they just want something simple. Because what if it goes wrong? What if something goes wrong? Maybe you want to put out a different message, right? How would we do that? Well, maybe we want to control our program a little bit, and if the user does something we don't quite like, right, we can say, I'm not going to do the insert, and I'm going to put out a message. Okay, how would we do something like that? And I realize I'm skipping around a lot of small things here. We will get to all of that, because again, I'm trying to show you things that are useful, and then we'll enhance and get all the little nuances here. Maybe I want some simple logic here, okay? And what I want to do is check to see if the job ID you sent me will be a certain length, not too long. Or maybe the max salary, we have a cap. We don't allow salary bigger than something else. Can I do this with a database constraint? Yes, but maybe just this program needs this rule, okay? So let's look at the jobs table again and look at our columns. And so max salary only allows up to 6. If you pass me a 7-digit salary, it's not going to go in, and I don't want this thing to fail. We can actually see what would happen. Let's go ahead and run this, and let's pass in a salary that is too long, okay, the max salary. Let's make it 850,000, okay? Or sorry, that's still 6. There, 8,500,000. There we go. What if we run this? And now we've got this. 8,500,000 greater than specified precision allows for column. Broken, they call it. Now, would they get this error back in .NET and Java? Yes. They'd have to interpret it and figure out what's going on. Or maybe I could say, oh, that's not a good error. I'm going to make sure that doesn't happen. I'm going to send something else out. We'll handle this 2 ways. And the first way, we're going to do it sort of the Neanderthal method. We're going to do it sort of the brute force method. We're just not going to allow it. How could we do something like that? Well, you need programming because you need conditional logic, things SQL won't do. I want to put a test that says, hey, if the salary is appropriate, let's do the insert. If it's not, let's not do the insert and change the message. The most basic logic command in almost any language is if, right? If. If says, if something is true, then I want to do something, right? And I'm going to put end if. This is the most basic sense in Oracle. If you do something is true, you have to have at least one executable statement, and you need some test here. The test could be something like this. I could look at the P max salary, right? And I could say, as long as this is less than or equal to, right? 1, 2, 3, 4, 5, 6. There you go. That's 6 digits. Now, I could also look at the length of it and figure it out. But if you make any more than that, you've kicked up to 7, right? As long as it's less than or equal to that, I will do the insert. Or I could also do the inverse, say, hey, if you're not this, I want to do something else. Let's do the positive first. We're going to basically make a true-false test that says if this salary, which is numeric, this parameter, is less than or equal to this number, then we're going to do something. We're going to do our insert. Let's take these 3 commands and put them in here. So, and I'm going to indent them. Okay. So the structure is if this is true, then we do this. If there's no else on an if, that's the only thing it's going to do. If nothing else happens, this program just absolutely won't do anything. All right? So let's be a little better. Let's add an else, which says it wasn't true. What do we want to do? Well, we don't want to do much. What I want to do is I want to change my out message, right? I want to send a different message back to the caller to say, oops, to say something along the lines of, create job failed, right? Max salary too large, something like that. It doesn't matter. We could be as specific as we want. All right. So the out message is going to be conditionally set. Either it's going to be set to the job was created, or it's going to be set to create job failed. Okay. Let's compile this. All right. Clear this off. This is our old run here. Now, we can run this again. We still have our test here. All right. Let's go to the jobs table and make sure we don't have the record. We're going to try it both ways. We still have our analyst in there. Let's clear them off again. Eventually, we'll code a little delete to make this easier, but we're just learning. And now we're going to run it with our run. So I'm going to run it. We should see the failure message. We're still there. So it says it ran, no error this time, but let's look at our output. And it looks like it says, there it is. Perfect. So our if worked. Let's run it again. Let's knock that thing down back to a normal, back to a normal size. There we go. And say okay. And it ran, and now there the job went in. And we can prove that because it'll be in our table over here. And it's down at the bottom, and there it is. Excellent. So we used some conditional logic to determine what our program should do. Should it go left? Should it go right? Again, the reason we're using PLSQL is to write programs like this. So we can have a program that takes care of any issues and does what you want it to do, which effectively is get this job into the database. Could I be more verbose with my messaging? Absolutely. I could tell them exactly what was wrong. It all depends on what you want to do. We're not going to get crazy here, but obviously anything you want to put out, you could. Could you have more than one out parameter? Absolutely. I could have two. Maybe I have agreed upon codes. Codes that say, hey, error 55 is salary's too long. You could have a list of these codes. You could do that. As many outs as you have, you can send out, and you can call them. One other concept, and I'm going to teach you this concept first before I show you how you can run this program not using the Oracle built-in run tool, how we can write our own, is the concept of hanging on to something in your program temporarily. That's called a variable. A variable is nothing more than a piece of memory that a program sets up to say, listen, I want to park something in memory for a while I'm running because I might need to reference it again. So variables are nothing more than spaces in memory. They exist as long as the procedure is running. When it's done, it cleans up the memory space. So it's not wasted memory for all time. It's just a one-time thing. Variables are set up using variable declare statements. That area in your program is between the word is and begin. This is the declaration area, as we call it. In a named block of code, the declaration area comes between is and begin. Variables are a lot like parameters. They need a name and they need a data type. Let's look at one. I'm going to make one called, I'm going to call it vMessage, all right? We're going to make this a variable character, but this time, variables have to have a length, okay? They must have some known data type with length, so different than a parameter. They don't have an in-out mode, right? Variables can be set, they can be overwritten, you can display them. They are free, like freely available to you in memory, all right? Unless you declare a variable as a constant value, it is mutable. You can change it. We're not going to do a constant here. This is a space. The default value right now in this message variable is null. Oracle sets them up as null. There's nothing in there. If I want to set it to some static message, I can do that, right? We'll see two ways of setting a variable here. So I'm going to use this vMessage so I can send out kind of a boilerplate message plus something custom based on what happens. So let's drop in. How can I assign a value to a variable? Well, a couple ways. In your logic section between begin and end, I can actually say it just like I would say something else. I can say vMessage is assigned a value of, right? And then I can put something standard, like here we go. Procedure completed with status. All right. I'm just writing that text. It's a character. I'm not at 100 yet. I'm in good shape. I got a vMessage here. What I want to do now is always prepend that to my out message. We're going to change our messages here a little bit. What I'm going to say here is, instead of saying job ID was created, I'm going to say the out message is equal to the vMessage concatenated to, right, the word success. Now they know that it worked, right? Okay. And actually I have a space. I'm going to pull this one off. And then here, I'm going to do the same thing. We're going to be a little more verbose down here. I'm going to say the out message is the variable, and I'm going to call this failed. Oops. Keyboard's floating on me a little bit. Failed, right? And then I'm going to put the reason here we're going to concatenate on. Actually, I don't need that extra cat. I was thinking I had a variable there. Let's do this. Failed. There we go. So the prefix on our message is always going to be procedure completed with status, which may be very useful to programmers. They're always looking for these words. Then they're going to find what comes after the colon to know if it worked, right? So this is now going to use this variable here in our message. Once this program's done, this gets wiped out of memory, okay? It sets it up. It's a variable assignment, as a variable statement, which says go do this during the declare. During the logic or the begin section, it says assign it with a statement. Now check my if statement to see what happened. Commit if it worked, insert and commit, send out a message. If not, just send out a message. Let's compile this. Okay, I'm gonna close this down. And let's run it again. Let's use our same little run. Let's make sure that we've got this out of here. Okay, and we'll run it with the run rig here. All right, we're gonna do the same thing. Let's make the salary too long, okay? Right there, that should take care of it. And now, I'm gonna bring this back up. We see it ran, and now we've got our prefix, there it is, failed. Okay, very nice. If we run it again, and we run it with the good salary, it should change, and we'll open this up. And it's success. Okay. Great. That's one way you can assign a variable a value. Just make sure you're assigning it something of the size and shape it's defined with. This is a character string. It needs to be characters. If I know that's going to be my message automatically when I set this variable, I can move this assignment up here to the actual declaration part of the statement here and just get rid of it. That says make it and assign it, and I'm good to go. It will do the exact same thing, has the same effect, and it saves me the statement in my program. Nothing wrong with that. They both work perfectly good. These are different than in parameters, right? In parameters are fixed. They're treated as constants. I can't assign them anything. They come in. Out parameters are empty. They have to be assigned something. You gotta assign it if you want to send it out. It doesn't have to be anything, but if you're gonna put something in there, you gotta call it. So now we're actually combining variables with some static text here to make a dynamic out message. So what I told you I would show you is, okay, that's great, I've been running this. How do I run this? How do I call this from another program? I'm not gonna have this little test rig, right? Well, we can do a very similar thing in our little run, and I don't need something as bulky as this. Let's take a look, okay? Let's see how we can run this when we're doing things like that. This was the anonymous block we used when we first ran it before we had the out parameters. How are we going to catch an out parameter from this? You know, we don't have that little bind thing. Even though SQL Developer would allow us to use that, that's not really how it would be tested in other programs. So let's use variables. Let's do the same thing, but with a variable. Now, when you're doing an anonymous block and you need a variable, you need to have the word declare, because we don't have the create or replace or the name of the procedure is. We don't have that section anymore. So the declare section, explicitly stated here by the word declare, is where all the variables are going to go. And we can make a variable here the same way we did before. We can say, hey, this will be the, v result message or something. It doesn't matter. Call it whatever you want. And it needs to have a length. Now I could probably figure out the length. I could look at first proc and say, well, I see how long it could be. What am I setting it to in there? But, for now, let's just go ahead and we'll set it to 200 because we know that's what it is. But you could easily coordinate with whoever the program and say, how long can this thing come out? How long can it be? If you have good documentation, which you should write on your code, you would tell people explicitly, these are my in parameters, these are my out parameters, here's how long they can be, here are the data types, things like that. So when you have the result message, you might think, well, how do I put it in there? Is there an assignment or something? Well, not so much. What we're doing is we're simply going to call the same program with the same parameters, but that fifth parameter, right, P out, we have 1, 2, 3, 4, 5, P out, needs to have a representation in our call. So I have 4 parameters here. The fifth one, it's an out, so I need somewhere for it to go, and that somewhere is a variable. It's a memory space. It's basically going to call this, and it's going to put the out parameter into the result message. And then later I'll show you how you can see the message. So let's see if this works. All right, let me go back to the jobs table here. Let's refresh. All right, our help desk is still here, so let's clear the help desk off this time because that's the one we used in our test program. Perfect. Okay, we'll come back and let's run this. We're going to pass in IT help, information, these values, and the result message. And this variable. So this is an empty hole in memory. There's nothing in it. It's going to pass it in, and hopefully the out parameter will be assigned to that. So we run it, and we get successfully completed. The question might be, well, how do you know what's in there? You don't. Remember what I said? When this variable is declared, it lasts as long as the program goes till end. Well, this is done. I need to be able to see this thing somewhere. We're going to introduce our first use of an Oracle built-in package, which is useful when you're trying to run debug statements. The way Oracle sends all of its code to you is in a container called a package, and they group related procedures and functions and things in a package. So if you know the package you want to use, you can reference the package code in your own programs. Packages are loaded into the Oracle database when the DBA installs it. And by version, there are slightly different packages, but for the most part, the packages I'm going to use have been standard for a long, long time. The package we're going to reference, we're going to call a procedures package, is dbms output. You may have seen this. And in that package, there is a procedure called put line, and we use a dot notation. So package, I can type package.procedure. And this procedure will put a line of text to a memory area known as the buffer. It'll put out any line of text by default up to 20,000 bytes, and that's configurable. What I want to do is I want to see what's in the result message. I actually want to print this off. So if I pass that, it's a parameter. This put line needs a text parameter that it's going to write to this buffer. DBMS output is nothing more than the package name. I have access to it because it's accessible to anybody who's connected to the database that's doing PLSQL coding. So this just says I'm writing a little anonymous block. I have a variable statement, do it. Run my first proc, do it. Now run dbms output put line, do it. That's what's going to happen. For us to be able to see the results from put line, I'm going to erase this and show you that initially you're not going to see anything. Let's run this. Oop. And now I have a unique constraint because I still have the IT help program in there because it's still there. When I deleted the last time, I did not commit. Perfect example. There you go. That's something maybe we want to track for, right? So let's come back here. Let's clear this off. That was an error we didn't plan on. We'll learn how to capture that kind of thing. If I run it, it says completed. Be like, well, where's the message? You said there'd be a message. Well, there is a message. I'm just not seeing the buffer. To see the output from dbms output, there's two ways you can do it. If you want to script it right in your block, which is I think is a good suggestion, you put this command. This is outside of any PLSQL. This is a system level command. Set server output on. This used to be a command we used in SQL Plus, was the command line tool to see server messages. It's still useful. If you have an open little window session here like HR, you can run this once and it'll stay on. I like to script it every single time. I'm going to run this as one complete script now. I'm going to set server output on, then I'm going to set this up. Now, I just added that record to the database. Obviously, it's going to have a problem. It's going to be a key, so let's delete it again. And it's gone, and we'll just verify that it's gone. It's out of there. Okay. Now, come back and let's run it. Now we'll see what happens here. Set server output on, and then do this. This is, again, not a PLSQL statement. It's a session level statement for this session I'm in to say, please display server messages. Run it, and now you see procedure completed with status success. That is what got put into result message. If you remember, first proc says, oh, if your salary passes the test, let's put out the message. Well, the standard message was procedure completed with status, and we added the word success. So now I can write my own little test scripts. I don't need that bulky Oracle test script. Although it's nice to have, it takes care of a lot of it for us. I am learning what it's actually doing. It's not doing anything you can't do for yourself. I don't care which one you use. Sometimes in this little tutorial, I'll use the quick and dirty Oracle one. Sometimes I'll write my own. I might want to do more things in here too. There's one other way you can see this output. So set server output on puts it right into your script output window, as you can see. Works perfectly good. There's also a tab in SQL Developer you can display that will capture all server output. You need to go to your View menu, and if you scroll down a little, you'll see DBMS Output. It's a special menu option on View. I didn't turn anything on. This is built into SQL Developer. If I turn it on, I get a tab down here that says DBMS Output, but you notice it's gray. And you'll notice it's set to 20,000. That's the default I mentioned. It's not on for any particular connection. I am connected as HR. These are my connections. I need to turn it on. So by doing that, I just simply select my connection, and now any DBMS output from anything within this connection will go to this window. Let's try our program again. Again, I need to come in here, and I'm going to delete the help desk line and come back here. Let's close everything down. There's DBMS output, and let's run this program. I'm actually going to take this command out, and I'll just run this script. And you see, here it is. It still did it up here because set server output was on in my session, right? But this is now capturing that output as well. And so if you like the idea of the window here, because you can clear it off and print it or save it or whatever, that's great. You can also simply do it in your script output. Sometimes script output is doing a lot of things, and it just gets busy. DBMS output is great. Again, you got to turn it on. You could have multiple connections that you're running output on. It needs to know which one. If you need to increase the size of the buffer because you're printing out an ignorant amount of messaging, you can crank that sucker up. I will show you in another section how you can actually find out what are the packages I have in Oracle. How did you know there was a DBMS output other than you've used it a million times? And then what are the options for me in that package? So we will look at that. For now, since we're trying to learn, we need a way to see things. Again, you can use the run from in here, and you can run, and you can simply get all these variables set up. They're declaring the variables as you see, assign the values and run it, and get the message that works. Or you can simply set up your own little clean test rig, and this works too. They're doing the same things. So there's one other thing that I said I would mention that is something we saw when Oracle set up its test script for us. And that was this kind of syntax down here of calling first proc, okay? You see this equals greater than, equals greater than. What's that all about? All right, let's talk about that. When you are calling a procedure like first proc, the parameters we're passing in are being passed in by position. So IT help goes to the first parameter. We know our first parameter here is pjob ID. Help information help desk, ptitle, and so on down the line. And then the result is being assigned to the out. That's called positional parameter passing, and it's the default. It works perfectly good. What if you explicitly want to tell Oracle, I want this parameter to have this value? Because maybe you want to call them out of order, or maybe sometimes you want to be able to skip a parameter, as we'll see later. You need what's called named parameter passing. It's the same concept. I need to put values in parameters, but I'm going to do them by name. So let's comment out this line here, and let's make a new call to first proc, okay? Let's call first proc, and whoops. See, even people that know how to write code make mistakes. You see all my mistakes. It's nothing magical here. We're just trying to show you the real world here. What I'm going to do is now I'm going to set values based on the name of the parameter. So let's say I want to set the job title first for whatever reason. I can now say p job title, and then I say equals greater than, okay? And I'm explicitly saying, give this parameter this value, and I can pass in this value here, okay? That's called named parameter passing, all right? I'm passing by name. I can pass them in any order, okay? I still have to supply something for every parameter in this particular case, but it can be any order I want. Just depends on what I'm feeling, all right? Let's do the p job ID, and that will be our IT help here. And let's do p min salary, and that will be our 4,000. And then p max salary, that'll be our 7,000. And now the same thing holds true for the out parameter. I can say p out message, oops, p out message, not p put message, p out message. And that's going to be our variable. All right, not a lot of gain here, but I need to notice two things. One is I got my parameter names based off the signature over here. That's what they're called. I need to use the right names. I'm still assigning them the correct information, but I'm doing it in a different order. I wanted job title first. No real reason to do that here other than illustration for teaching purposes, but there'll be a reason sometimes, and it usually happens when we want to skip over a parameter that has a value we don't want to change, some kind of default. Okay, so this will call the same program here, passing it in with named parameter passing. Now that I've got that, I can take off this extra paren, and we're still going to print out the message. So I haven't changed my program. I'm just changing my test script. Let's go into the job table. Let's get rid of the help desk again. We're about to make that better. And it's gone. And let's run our test script and see if we can see something. Let's erase our DBMS output buffer here. Clear it off just so it's nice and clean. And let's run it. And there it is. Success. Perfect. That's named parameter passing. You will see a lot of the Oracle documentation use this syntax. You don't have to, but it is very explicit. That means you, the reader of this code, says, I know exactly what's going in. Hey, sometimes you get things messed up. You can imagine that if we came up to first proc up here, and I just swapped this 7,000 and that 4,000, it would still run. It's just positional. They're both numbers. And it may take me a while to figure out I made a mistake because it looks good in the database, right? You're like, whoa, why is the low salary so much higher? What's going on? With named, I actually have to get involved and say it, and now I'm reading it like min salary. Yes, that makes sense, okay? It's not saying salary is greater or equal to 4,000. It's saying this is a assigned, like an assignment also, but not, it's more like a parameter bind statement, okay? It says explicitly take this name parameter and give it this value. Again, one of the main reasons we do that is sometimes we want to skip a parameter. Well, you can't skip a parameter that doesn't have a default value because as we saw before, it'll say wrong number or types of arguments. Let's say you did want to default a parameter. Let's say that minimum salary is always 0. You're always going to set it to 0. That's cool, meaning if I don't want to change the min salary, I don't have to. Well, first off, how do I tell Oracle that procedure needs to tell that parameter you're 0 by default? Very simple. Let's come back to our proc. In our parameter list here, where we put every name and the type in and then the data type, if we want a default value, we have two options. Let's say min salary want to have a 0 if it's not specified. You can use the assignment operator and say : equals 0, like that. That's perfectly good. Most of us do it that way. Or you can say default 0. Either way works for me. Let's go back to the assignment version. Likely to see this. So now I have this procedure that puts a 0 into that. Okay, great. No problem compiling. Looks good. How do I know that? Well, first off, it's not going to tell me that over here. So if I start handing this procedure out to people, I need to give them some documentation or paper that says, by the way, min salary is defaulted to 0 if you don't use it. Like, okay, cool, thank you. But how do I call it? Looking back at our anonymous block we used to test, let's do a couple things to see what the net effect of defaulting this parameter is. First, what I'm going to do is I'm going to comment out the call we just used with name parameter passing, and I'm going to uncomment the original, which does things by position. And if you're familiar with any other languages, or maybe you've seen some code before, sometimes when you want to skip a parameter, some languages will allow you to just take it out and do like a comma, comma. Oracle does not. PLSQL does not like that. In fact, you can see from the red squiggly line here, there's a problem. We're going to try to run it anyway. Let's see what happens. And we get the issue here. I encountered a comma and expecting something else. Yeah, I need something. When Oracle sees a comma, it says there better be something after this, and it better not be a comma. So that doesn't work, clearly. You might think, well, I'll put the word default in there. In fact, if you run this like this, if I could spell default correctly, it doesn't look like it's an error. It actually looks, wow, that looks maybe pretty good. Let's see what happens here. Let's run that. And we get, nope, it Doesn't like default. Default, even though it's an Oracle keyword, does not work in this situation as a parameter. So that's no good. So you're kind of in trouble here. You don't have any way in positional to skip this parameter. The only way it would work in positional is if it was the absolute last parameter in a call and you just left it off. It's not the last parameter, it's the third parameter. So we have a problem here. None of these are going to work. Let's just put it back to 4,000 like it was for our little test. Named parameter passing to the rescue. With named parameter passing, we just don't call it. We'll just skip it. So all I have to do is take out this call here, the min salary, and this call will just assign values by name of these other things, and since min salary has a default, it will use it. If I passed a value in, it would use my value, but I'm not gonna pass a value in, I'm gonna let it default. Let's open up our table again here, and let's look at our data in our jobs to make sure that it's not in there, because we're gonna be running the information help desk again. And looks like we're good. No IT help desk. In fact, we could just sort these by IT, put them all in the middle. There we go. Let's run our program now with our default parameter of 0. Okay. I still have my output on, and we still have gonna put our little message there. And now I got a success message. Let's take a look at the data. We refresh. IT help 0. Perfect. Exactly what we were after. If we open up our procedure, and mine closed because I had lost my database connection, a little pause in the video there, sorry about not telling you about that. I have a default of 0 here. That allows me to skip that parameter using named parameter passing. So that's the advantage of named. Obviously, no one's gonna know that's a 0 unless you tell them. So yeah, printing up a little documentation doesn't hurt, and also letting people know what you expect in that field if they are going to put something in there. So where are we at? We have a procedure. We have parameters. We've defaulted one to a value. We have some conditional logic here that decides what kind of message to put out. And in our test program, we're skipping said parameter. Just to show that it would still insert something if you use the parameter, not a problem. Let's put it in there. Let's put 2,500 as a value in there. I'm going to go ahead and remove that job again. We'll kill that out of there. And let's run this and see if in fact overrides that default. Okay, we'll clear this. We'll clear this. Oh, I lost my DBMS output. Have to bring that back on. Let's look at the DBMS output here. Let me view and turn that guy back on. There he is. Okay, success again. I just closed the window on accident. And let's refresh our data. And 2,500. Works exactly as advertised. All right, let's add one last thing to this initial procedure that we're using for training here that we're going to use throughout any demonstrations that we do. We have a procedure. It manipulates a row in the database, puts out a message to us via an out parameter, and we have a little bit of logic in the procedure. What about basic error handling, though? What about handling errors that Oracle throws at you that have nothing to do with us deciding it's an error? Well, in any block of code, there is an error handling section if you choose to use it. It's called the exception section, and it syntactically comes before the end keyword, but after all the body text, basically. So we put the keyword exception here. And what we put in this section are statements that handle errors. And they're in the form of when, then. You know, when this happens, then do this. When this happens, do this other thing, and so on. And you can have as many as you need to handle the exceptions. One possible exception we might have in this is, what if we did pass in a job ID that violated the primary key? Pretty standard database check. The database is the constraint, the key is protecting us from that. But the program crashes, as we saw. We saw that we had that error. I said we would handle that. Let's take a look. To understand the exception, you'd use the Oracle reference manual that I'm going to show you at the end of this little narrative here. But you need a when statement that calls out the exception by its name. The name of the exception that Oracle has built into PLSQL when you violate a key is called dupe val on index. And what this is actually, it says, the index that supports primary key has found a duplicate value. So it means anywhere in this block of code right now, anywhere I violate a primary key, this is going to be tripped. And what happens is, and I'm just going to do nothing for the beginning here. The flow works like this. As a program is running, and it gets into things it's doing, like declaration statements or logic statements, when an exception is thrown, control stops immediately at that statement, and it is transferred to the exception keyword. And the exception then starts to look for which when caused it to be called. So if I'm trying to look for the fact that I inserted a duplicate primary key violation on this table, if this is the statement that throws the error, it's going to stop. It's not going to do any of this. It's going to skip all the rest, and it's going to just unconditionally branch out and get to this keyword and look for that when dup val on index. What do I want to do? Well, maybe in this situation, I want to tell the person that supplied that value that can't do that. We already have that. Why can't we use our pout message? We perfectly can. Instead of just throwing some hard error and breaking the call, why don't we go ahead and just send a different out message out and say, it's failed. Same thing. We'll use our same little variable, procedure completed with status failed, but we'll say something like job ID already exists. There we go. Why can't we just do that? So when there's a duplicate value in index, let's do this message. Fine. Let's compile this. Okay, get our little compile here. We got our DBMS output. And now, I already have the help desk in here, right? We've been deleting that over and over and over. Let's not do that. Let's try to put it in again. This is the key. Job ID has been set up as the key of that table. Maybe it's not the greatest key, but that's what was set up by Oracle in their demonstration. So we're going to make sure that we don't duplicate that. So let's run this script. Boom. Error. Failed job ID. Now, the key here is the program did not fail with an unhandled exception. If a PLSQL procedure fails with an unhandled exception, a lot of stuff can go wrong. Number one, out parameters usually aren't set. Two, any pending transactions may be rolled back. Certain types of global variables may not be set. So we don't want that. We want the procedure to end in a way we determine it to be successful. It was a successful procedure. It ended the way we intended. It did it by saying we had this problem. What else could go wrong? Well, I don't know. What if a value was too large for one of these columns? I might not know what all the things could happen are. I'm not sure. There is a catch-all error handler you can use, and that is called the others. So we can have as many of these as we need. We can say when others, which means anything else went wrong, then what do we want to do? Well, then maybe we just change our little pout message here, and we'll say something like this. Hey, it failed, some other DB error. Okay, and we know if we see this, whoa, something happened we didn't think about. It was a database error, but I'm not sure what it was. I'll do a little nice code formatting here and indent for you here. Okay. So let's compile that. Well, what kind of database error could it be? Well, it very well could be that, for instance, we try to insert a value into job title that's too long, or into job ID that's too long, or something like that. Or maybe, and this is not set up in the database, that the salary itself, right, is too long. Now we have the max salary that makes sure you're not over that limit, right? Maybe we don't want to do that. Maybe we just want the database to handle it. Let's start with the job title. Let's see what we have in job title here. And as far as the columns go, job title can be 35 characters. So we want to make sure that we don't violate that. Okay. So when we run this now, a couple things. We already know we're going to fail on duplicate value on index. So we need to make sure that doesn't fail again. So let's go ahead and let's remove the help desk again, so we have that to play with. But let's use longer than 35 characters. Let's do something longer that exceeds 35 characters as far as this goes. So we got information help desk with a very long description that won't fit, right? I think that looks like 35. What do you guys think? I'm going to guess. That's at least 35 characters right there. Let's see what happens when we run this time. Okay, some other DB error. So I don't know what that error was, but I realized it wasn't duplicate value in index, and it wasn't the fact that I tried to put more than a 6-digit salary, because I have my own if condition checking for that. How can I find out? It's great that it failed, but I have no idea of knowing. I have to look, right? Well, there is a way. If you want to echo out the last error message that Oracle had that caused it to have an exception, there's a function that will do that for you. Functions compute and return values. We're going to write our own functions, but built-in functions Oracle do the same thing. They send you something back. They're kind of like a procedure that always has an out. A function always has what's called a return. It's going to hand you something. And what we're going to look at is we want to put the message that it failed, but right here, I would like to concatenate on whatever comes out of the error function, and that function is called SQL ERRM, SQL ERRM, as we say. This will give me the message that caused this others to trip. Let's compile this, okay? I don't have to worry about erasing the job this time because it didn't go in. My program had an unhandled exception, right? Not unhandled, but had an exception, so none of this happened. Right? When it tried to do the insert, it tripped. It didn't do it. Never got to the commit. It came down and said, well, it wasn't duplicate value in index. It was something else. So the others happened as the fall through. Let's run it, see what we get. There we go. Now we're getting the SQL ERRM. You'll see it down here. This wasn't designed by me. This is coming straight from the database. Hey, this value's too large for the column. Actually 64, maximum 35. Very good information to have. Really, really nice. That tells me exactly what is happening. Okay, so key piece of information here. Exceptions are read from top down, fall through logic. So others needs to be last. Everything is an other. Duplicate value in index is an other. Just because it's in there, it won't look for it. It finds the first one that matches. And if others is first, everything will match others. So put it last. In fact, a really great framework for a PLSQL procedure is always to have an exception when others and something like this, so you always have some kind of catch-all error handling, so at least you have something, right? And then way the developer or programmer using your code can say, hey, I got this error, it said column was too long. Like, yeah, you passed in something too long. Now, could they control that from the front end with their screens? Like, hey, don't allow people to type more than 35 characters in a box. Sure, but why can't we make our code resilient too? Say, listen, you may not be good at doing that, or someone tries to inject something in, security problem. I'm going to make sure it's not longer than what we allow. So that's giving you that capability. This brings up another question I said I would answer, and we're going to do it now. How do you know what you have? Am I just making up these names? How do I know them? Well, I've used them a while, but I had to reference them at first as well. So how can you find out what version of Oracle you have as far as capabilities for exceptions, and also what built-ins do you have? Let's go to the web. It's great that you have web now. And if we go to any of the Oracle documentation, or if we say Oracle PLSQL reference, let's do this, reference. Okay, let's bring this up. This looks like 18C, that's fine. Oh, it's even telling me now, older release. All right, let's view the latest release because I am on 23 in this demo. There it is. Okay. This is a simple reference manual for PLSQL. It's not like here's how you build applications. It's like I'm telling you stuff. If you look on the left-hand side, we're going to use this. It tells you a lot of really cool things. Down here, error handling. Okay, let's take a look at that. Error handling is telling us all about the exceptions, and then it'll tell you here, there's a section called predefined exceptions, meaning these are error codes that Oracle has assigned names to, so we can use them by name, like the ones you saw. There's actually not that many. We can do any one we want, but these are the most common ones. And this table here tells you all the names you can check for with a when. There's the dupe val on index right there. It tells you the error code that Oracle throws too. Maybe I need a no data found. We'll see that one later. Or maybe, hey, too many rows, or I'm dividing by 0 or something. Okay. These are names you can reference in your whens to say, if this happens, I'm going to do something. How can I trap for any error and give it a name? You can. You can make custom error messages, custom error names, and you can trap for them because Oracle has thousands of potential things that can go wrong. But for the most part, these will take you a long way. That's giving us the Oracle predefined exceptions. So you need your PLSQL reference manual. Now, what about packages and types? Let's use the little search bar up here. And let's see if we can find this reference here. Oh, you know what? Let's do PLSQL reference. This search bar, not so... There we go. Okay. Let me see if I can find the package and types references here. Not letting me find it. Let's try this. Even I struggle with this sometimes. Oh, there it was. I just had it. So here we go. This is a version 19. It'll be pretty similar. Why am I looking at a packages and types reference? The packages and types reference will tell you the packages you have. On the left, these are the names of Oracle packages by chapter. All right, they all have different names. If we scroll down to the DBMS output, alphabetically getting down there, it's a ways down there, it's right here. If I click this, what you're looking for is, obviously you can read and it tells you all about it and here's how it works and this is the intent. If you want the quick and dirty, what you're looking for is the summary of sub-programs, meaning what's in this package. If I open this up, it'll tell you what procedures, functions, types, whatever you have are here. These are all procedures, and there's our put line procedure. This says, hey, I place a line in the buffer. We know that. We've seen it work. What does it really do? You can click this, and it tells you, number one, the signature. Here's how you use it. Look, it's like a procedure like yours. Hey, there's the name of the package procedure. There's the parameter name item. It's an in parameter, and it's varchar2. Okay, cool. Again, no length. And then item tells you what it means. Oh, this is what you're going to put in the buffer. And then if there are any specific errors that this thing might throw, Oracle tells you because you may need to trap for them later by code, right? How long you're doing something or whatever. And then it also will give you usage notes. You can go to Google and Google DBMS put line, and someone will tell you what's going on. But in here, you're getting the authoritative information from Oracle. Here's everything. No one in a little web demo tells you all the nuances of what's going on with put line. So use your reference. If you can use Oracle's reference and you have it, you're good to go. I need SQL developer. I need a database connection. Give me my reference. What code do you want me to write? I got to know your database. Let's start writing code. So this is the authoritative area. Oracle usually gives you a little example. If you want to try something, they'll give you a little test script here or something you can try. So you can see they're using the set server output on as well. They're doing this from the command line, SQL+, but that's fine. It works in SQL Developer too. The SQL window in SQL Developer is equivalent to SQL+ pretty much. So now I know what I have. So when you're looking for things you want to be able to do, right, like DBMS output put line, like I have in here, I have that. That's part of my Oracle version. What can I use for exceptions? Oh, I can look those up too, right? Dupe, val, and index. Perfect. Now we're programming by reference. Now we have access to things. Any SQL function you've used, uppercase, lowercase, 2 character, 2 number, any mathematical, anything, works in PLSQL the way it works in SQL. You have the entire suite of functions available. If you didn't know, those functions actually are deployed in a package called standard. They don't show you the standard list of packages, but standard is the main package that has all the data types and all the built-in functions and things like that. So, and standard is always available. You can reference them without saying the name of the package. You can simply use the function. So if for whatever reason I wanted to make sure my message here went out all in uppercase, I could take this, right, and say upper of all of that. I know I've mixed it in case there's no point, or I can put it up here as well. Maybe if it's successful, I can put it over here too. I can wrap any SQL function around something that it makes sense to do so. Down here, I'm going to leave these just the way it is. So let's compile that. And let's go back over here. And let's see if we got the job. I don't think it went in. It did not. Good. And let's fix our description so it's not so long anymore. And let's run our program, and let's see what we get. And let's get our DBMS output. I closed that on accident again. I do that a lot. That one I tend to close. Not sure why. I like to keep my screen clean, and I'm on kind of a small monitor here for you guys. We get used to it. All right, let's run this. And now you can see all uppercase. Perfect. That's a lot of information throughout the first part of this tutorial. I am going to end this video. What I suggest you do is look it over, watch it again. I'm going to try to start to address some of the things that we left off. We didn't do everything in the next video. And also, we're going to start to add the ability to put programs into packages. We're going to add more code. For instance, we're going to add a delete procedure so we can remove a record. So if we want to add it again, we don't have to worry about manually deleting it from the interface. We'll look at how do we update records as well. How can we find out what happened in an update? We will also start to advance our variable declarations to make them more powerful. We will start to use some new types of variables called records. So I want to add all of that, and that'll be in the next video, which I am currently compiling. So for now, practice and check back. I will have another video for you very soon. Thanks for watching.